You type your password, you hit enter, and in less than a second, you're in. But where did that password actually go? Because I promise you, it did not go where you think it did. Most people assume something simple happens. The password travels to a server somewhere. The server checks it. It comes back with a yes or a no, and that's it. Except that's not what happens at all. What actually happens is something most people never think about, and once you understand it, you'll never look at a login screen the same way again. The moment you hit enter, your password leaves your device, but it doesn't leave naked. It gets wrapped immediately in something called TLS, encryption. Think of it like a sealed envelope that nobody can open except the person it's addressed to. Anyone watching your network traffic right now, your internet provider, someone on the same Wi-Fi, anyone in between, they see nothing. Just noise. Just random meaningless data flying through cables. Your actual password is completely invisible to them. It travels that way, sealed and protected, all the way until it reaches the server. And that's where things get really interesting. Because here's the part nobody talks about. The server does not store your password. It never did. Not a single company that actually knows what they are doing has ever stored your real password anywhere. Not Facebook, not Google, not your bank. None of them. What they store instead is something completely different. It's called a hash. A hash is what your password becomes after it gets pushed through a one-way mathematical function. Think of it like a blender. You put your password in. The blender runs. And what comes out the other side is a long scrambled string of completely random-looking characters. Here's the critical part. That blender has no reverse button. You cannot put the scrambled output back in and get your password out. It is mathematically impossible. The function only works in one direction, so every single time you log in, the same thing happens. You type your password. It gets blended. The output gets compared to what's already stored in the database. If they match, you're in. If they don't, access denied. The server never saw your real password. Not once. Not ever. It only ever compared two scrambled outputs and checked if they were identical. But there's one more layer to this, and it's what makes the whole system genuinely clever. What if two people use the exact same password? Without extra protection, their hashes would be completely identical in the database. And an attacker who got inside could immediately spot that pattern and exploit it. So good systems add something called a salt. Before your password gets hashed, a random string of characters gets added to it. Something unique to you. Something nobody else has. So even if you and a million other people all use password 123, every single one of you ends up with a completely different hash in the database. No two are alike. No pattern to exploit. This is why when companies get compromised, if they did everything right, all anyone finds are hashes. Scrambled strings that cannot be reversed. They can try to guess, running millions of common passwords through the same function and comparing outputs, but modern systems are specifically designed to make that process take years, sometimes decades. The system was built to protect you even when everything else has already failed. Think about that for a second. Your password never traveled as itself. It was never stored as itself. From the moment you hit enter, it got wrapped, scrambled, salted, and transformed into something unrecognizable. The protection happening behind that login screen is invisible, but it never stops running. So here's the question that should be keeping you up at night. What happens when a company skips all of this? When they store your password exactly as you typed it? No hashing, no salting, nothing. Just plain text sitting, waiting to be found. It has happened. At some of the biggest companies in the world. Companies you have almost certainly used. That is a story for another time.